Okay, folks, we are on Chapter 16, PowerPoint Slide 12, the first problem, which says at some temperature, the equilibrium constant K is 33 for the reaction H2 gas plus I2 gas reacts reversibly to form 2 moles of HI gas. Initially, we have 0.006 molar of both hydrogen and iodine, and we have no HI. Some change is going to happen to get us to equilibrium. What is that change? Well, we don't know. Let's say we're going to lose some reactant, X. We're going to lose X amount of hydrogen. Once I set that, we can see that we're going to also lose X amount of iodine because these react in a 1-to-1 ratio. We also see we're going to gain 2 moles of HI. So if we start with an initial concentration and we lose X, we're going to end up with 0.006 minus X hydrogen, 0.006 minus X iodine, and twice X hydrogen iodide. Now we can set K, the equilibrium value, will be equal to the concentration of HI at equilibrium. Don't forget something. You need to square it. The concentration of everything raised to their stoichiometric powers. When we do we do products over reactants, which are H2. I don't need to square this because there's no stoichiometric coefficient out in front. It's just 1. And the equilibrium concentration of iodine, that should be equal to 33 when I'm done with this. So now we're going to plug in the equilibrium values, which we don't yet know, into this equation. We're going to try to solve it. Let's see what happens when we do it. So I'm going to take twice X, and I need to square that. That's my equilibrium concentration of HI. I'm going to divide that by the concentration of H2 at equilibrium, which is right here, and the equilibrium concentration of iodine, which is right here. And I need to set that equal to 33. Now we can simplify the algebra if I just simply take the square root of both sides of this. If I do that, the square root cancels this being squared, and this is on the bottom. If you look, it's this times this, so it's squared. So I'm just going to get rid of 1. So I'll end up with, on the left-hand side, twice X over 0.006 minus X, that quantity, that should be equal to the square root of 33. Well, what is the square root of 33? Well, let's turn my cell phone sideways here. So this shows up. I'll type in 33. I'm going to take the square root. Right there it is. Looks like 5.745 if I round. So we'll use that. Yeah. Although I want to get rid of this denominator, so now I'm going to multiply both sides by 0.006 minus X. That cancels this. And that is now going to give me twice X is, what's 5? Okay, I got to distribute here, so I'm going to do 5.74 times 0.006, and then I'm going to do 5.74 times a negative X. So what's 5.745 times 0.006? That's going to be 0.034. That looks like 5, doesn't it? I'll round to 3 significant digits there. That's this times this. Now I'm going to do 5.745 times a negative X. Well, that's easy. Negative 5.745X. All right, let's get all my X's on the same side. We'll add 5.745 0.745x to this side of the equal sign. And now we got to do the same thing to the other side of the equal sign. That cancels. And I am left with, what's 2 plus 5.745? That's 7.745x. That's going to be equal to 0.0345. We're getting close. I want to know what x is. So I divide both sides by 7.745. And I get x equals whatever this is. Let's find that out. .0345 divide by 7.745. 0.045 we'll call it. Now let's see if we've answered the question. If we were in math class, we'd be done because we found x. But we're not in math class. We're in chemistry class. What was the question? Oh yes, I was supposed to find the equilibrium concentrations of hydrogen, iodine, and HI. Now my value for x, which I found here, that's certainly going to help me get there. But I'm not there yet. So, let's get there. All right, we found x to be 0.0045. Notice that the equilibrium concentration of hydrogen is the same as the equilibrium concentration of iodine. See that? Which is 0.006 minus x. Let's see what that is. That's 0.0015 molar. That's nice. And now, the hydrogen iodide concentration at equilibrium, that should be 2 times 0.0045, which if you run the math, that's going to come out to 0.009 molar. So that's going to be my equilibrium concentrations of hydrogen. Iodine is this. My equilibrium concentration of HI is this. You know me, I like to check to make sure everything makes sense. So I'm going to do the following. I'm going to recall that the equilibrium constant, that's supposed to be 33. And that's supposed to be the equilibrium concentration of HI squared divided by the equilibrium concentration of H2, and also divided by the equilibrium concentration of I2. Well, that should be equal to, let's see, HI, that's 0.009, and I'm going to have to square that, and I'm going to divide by, here we go, 0.0015 for H2, and 0.0015 for iodine. Let's find out what that is. All right, here we go. Watch how I do this in my calculator. 0.009 times 0.009, that's 0.009 squared. Now you got to be careful here. I want to divide by this product. I'm going to do it the way I normally do it, and I'm going to show you a way that people will mess this up. So remember, this is the numerator squared. Now I'm going to divide by 0.0015, and I'm going to, that's that, and I'm going to divide by 0.0015 again, and that's equal to 36. That's very close to 33, and because I was rounding, it's not exact. As long as you're roughly close like this, you're going to be in good shape. You know, I'm within just a couple percent. Now let me go back and redo this particular calculation with my calculator in a way that I sometimes see students do it. Because see, a student will sometimes see this on the denominator and will think 0.0015 times 0.0015. And because of that, they'll plug this into their calculator like this. Watch what I do. 0.009 times 0.009. I just calculated the numerator. And now I'm going to divide by 0.0015 times 0.0015. See, I did this in my head, but the calculator saw me do something very different. I'm going to write out here what the calculator saw me do. It saw me do this. 0.009 times 0.009 divided by 0.0015, and then it took this answer, because I said times 0.0015. Be careful you don't do that. I need to make sure I divide by everything on the denominator, and you need to make sure that you communicate to your calculator correctly what it is that you want the calculator to do. And all calculators are programmed to work in a particular way. You've got to make sure that you understand how your calculator works.